Using RailClone to create your own 1D and 2D arrays couldn't be easier once you know a few simple principles. In this tutorial, we'll create this Seaside Promenade image and demonstrate the most frequently used features of RailClone. To get started, make sure you've downloaded the scene files from the Itoosoft website. Once you've downloaded these, start by opening either vraystart.max or mrstart.max, depending on your renderer. The current scene has some elements already in place, including all the trees created using Forest Pack, and a building perched on the distant headland. Also in the scene are all the splines and objects required to create the seawall using RailClone, including the pavement, the balustrades, ivy, and the lights. To get started, create a new RailClone object by going to Create Itoosoftware and selecting RailClone. In the viewport, simply drag out a new RailClone object anywhere in the scene. An icon reading RC will be created. This displays when the RailClone object is not currently generating any geometry. Open the Modify panel and rename the new object RailClone Fence. Now access the library browser by going to the Style rollout and clicking on the Style Name Selector button. This will be displaying none as no style is currently selected. The library browser will open in a separate window. Once in the library browser, from the File Navigator on the left hand side, go to Libraries, RailClone Library, Architecture, Railings, Exterior, and select Iron Handrail 4. Either double click, select Import This, or right click Use Items to import them into the RailClone object. With the style loaded, you will see a preview image and the name updated in the style rollout. The style will also have loaded any necessary inputs it requires into the base objects and parameters rollouts. In this case, the style needs a single spline to determine its path. Go to the base objects rollout and select Spline from the list. From the Properties section, click on None to activate the Spline Selection tool and pick the spline named Railings from the scene. The railings have now been created in the scene. Finally, we'll adjust the material from its default black metal to a dark green. Open the material editor and use the eyedropper to pick the material on the new railing object. This is a multi-sub-object material used on a number of handrails in RailClone Library. Double click on the material called Black Metal 1, attached to the Material ID 2 slot. Now change the diffuse colour to red 3, green 23 and blue 7. If you render the scene now, you'll see a green railing to the left of the scene. In this section we've learnt quickly how to create RailClone objects, navigate the style library, import library styles and pick base objects and adjust materials. Next up, we'll make a new one-dimensional array and create a sophisticated style for the balustrade on the right of the footpath. In this section we'll create a new style using these 4 segments. A rule set will be created to array these segments along a single spline, repeating the balustrades, interrupted by pillars placed at regular 5-meter intervals, with lights that sit atop every other pillar. Let's get started by creating a new RailClone object. Come up to Create, to Itoosoftware RailClone Pro, and drag out a new object in the viewport. Go up to Modify, and you want to find the Style rollout. We're going to create a new style by opening up the Style Editor. Click on this button here, Open Style Editor, and the node-based Style Editor will open. To use it, on the right hand side you have all the various nodes that can be added. We have generators, objects, parameters, operators, and also notes. These are created by dragging them from the items list into the construction view. So in this particular instance we want to create a new linear array. We'll do it by dragging it from here to here. And then on the left hand side you have all the different properties for the node you currently have selected. Once you have a generator, the first thing you need is a spline. This will determine the path used by RailClone to distribute the objects. Let's drag a new spline node from the right hand side into the construction view. With a linear array, there are really only 2 sections that you can connect a spline to. In this particular case, connect spline to the spline input. You can't pick the spline from the scene directly inside the style editor itself. Instead, it shows up in the base objects rollout of the main plugin. This is so that you can easily share and reuse styles once they've been created, without having to open the style editor to reallocate the spline every time. To pick the spline from the scene, come up to Base Objects, click on Spline, click on the spline picker here, and pick a spline called Baseline from the scene. You'll see it's now allocated. If you want to rename a spline node, simply type in a new name here. I'm just calling this balustrade path. and you'll see when I hit return, it automatically updates in the base objects. Rollout. It's a good idea to give your splines names so that it's easy to understand their usage. Now that that's done, we need to add some segments, some geometry to distribute along this path. To do that, come into the items, find the segment object and drag it into the construction view. Now this one can be picked directly from inside the style editor, and to do that come over to the properties here, and where it says object, none, click on none and simply pick an object from the scene. In this case we want this ballast mid geometry object. That's loaded in and the name's updated to reflect the geometry. Now what we want to do is to connect this to one of the input nodes of the linear array, and the one we'll be using here is the default input. The default input is what will distribute the object all the way along the path from start to finish. This will display unless one of these other inputs is currently in use. Let's just connect that by dragging the output slot here to the input and the default. And now you can see immediately that's updated in the viewports, running the full length of the spline. By default, RailClone is using our point cloud display mode. This makes it very easy to see an estimation of what this will look like in the final render, and keeps it fast and interactive in the viewports. However, when you're first creating a style, it's helpful to be able to see the full geometry, so you can check that everything fits together perfectly. In order to do this, we want to turn off point cloud and show the full mesh, but obviously if we do this along the full length of the spline, viewport performance is going to become unmanageable. What we'll do is just display the geometry on a small section of the current spline. In order to do that, come over to the base objects rollout, come down to here where it says full length, and turn that off. The position along the spline is now governed by these two parameters. A start point, which governs where the RailClone object starts creating the spline. You can see as I turn this up, the object is moving along. If I turn it up a bit faster, at some point, there we go, we'll see the start point go beyond the camera lens. So you can see as I move this start point up, it's pushing everything down along the path. Let's keep it in the camera view. And then from this point, measured from this point down the spline, we have the length, which is set very high at the moment. Set this to 100 meters, let's say. And you can see now it no longer extends all the way along the path. Let's shorten it down a little bit further. And you can see it moving back. We want, say, 25 meters of path to work on. So now we've got a manageable section. We can turn off the point cloud display by coming to the display rollout, in the viewport section, turning on mesh. Now you can see the full geometry. So let's isolate this and these segments so that we can work on this a little bit clearer. So I'll select all of those and hit Alt and Q and grab that. And I might just change my layout a bit too. Now that we've got the basics done, we want to add these pillars at regular intervals and the start and the end. To do that, we need a new segment object. So just drag it into the correct construction view. Select the pillar from the scene by clicking on Object None. And again, you'll see the name updates. And we want one at the beginning, one at the end, and then evenly. So let's connect this one to the start. See, one starts over here. We want one at the end, so we'll connect that down there. You see one appears on the left-hand side. But we also want them spaced in between at regular intervals. So to do that, also connect this to the evenly input slot. And there you can see regularly spaced pillars. If I go to linear, to the rules under properties, at the bottom here there's an evenly rollout, and this is what controls the distance between them. If I turn this up, you can see the spacing gets larger. If I turn it down, the spacing gets close together. We want to set the spacing at about 5 meters. Now, also in this case, I want to turn off justify. If justify is on, the space on the far left hand side and the space on the far right hand side are equalized in the event that the spline isn't a multiple of, in this case, 5 meters. That's fine, but we're going to be adding 2 RailClone objects, the lights on top, which have different distances, and they don't always line up that well if Justify is switched on. So in this case, to turn it off. So you can see that the adjacent segments next to the pillars are leaving a small gap here, and that's because this is positioned at the widest point of this segment here. Because of the curved top, it's leaving a bit of a gap. So what we need to do is to move these segments over on both sides. But of course, if we do that, the pillars here are going to be too close to the balustrades, so this distance is going to close up. What we want to do is to add a small filler section seen down here, just to make up the difference, so that when we pull these in together, the gap doesn't get appreciably smaller in between. We could have made 3 different pillars for that purpose. One on the left hand side, which has a small piece of filler on the right, one on the right hand side, which has a piece of filler on the left, and then of course the one in between, which would need a piece of filler on both sides. But that would, be 3 times as much geometry as we really need. What we'll do instead is add this filler to the stile here, and then combine it in the stile with the posts. So let's add a new segment for the filler, and then pick it from the scene. And now we want to combine them together. So let's just disconnect the default segments for a second so we can see a little clearer what's going on. We'll work on one of the mid ones first of all. To combine together different segments inside of a stile, we use a compose operator. Let's drag that into the scene. And to use this, you simply connect them in the order you wish them to appear. So we'd want a joint first, then a post, and then another joint. And let's just connect that to evenly, since it's a midsection. So now you can see with this compose operator, I've got a joint here, then a post in the middle, and then another joint afterwards. That doesn't actually solve the problem of them not closing up the gap, but we can fix that now. So to do that, go to ballast post in general, and there's padding. And padding controls the position of adjacent segments. So in this case, to close up this gap on the side here, we'll just turn down the left segment. And you can see that as I change this, it pushes and pulls that adjacent segment further away if it's a positive number, or intersects it if it's a negative number. In this case, we want about negative 0.4. 0.4. And then the right hand side, you should get the same effect. So you can see if I make it a positive number, it moves away, and a negative number, it gets closer. I'm obviously looking at this from the wrong side, so I'll just swing around the other way so it makes more sense. Now hopefully the left hand side is on the left and the right is on the right. Oh. There we go. So that's the middle ones done, but if we look at the ends, we haven't fixed those yet. So we want another compose operator. In this case we just want a joint and then a post, and then we can connect that to the start. Now you can see that I've got this on the wrong side, which means that these are in the wrong order, and that's great because that lets me demonstrate how we can change the order of these. It's not necessary to disconnect them. All you need to do is click on the name, and this brings up an up and a down arrow on the right hand side. If I wish to change this, the order of this so that this is above the ballast joint, I just click on the up arrow and they swap places, and that fixes that. And then to create the last one on the end, let's just move over and find that. Here, I could create a new compose operator, but instead we'll look at another feature which is a reverse operator, which works in tandem with compose and basically just switches the order that's in the compose it's connected to. So if we just grab this reverse, wire this compose into this reverse operator, and then wire this reverse into, in this case, the end, you can see now that it's got the fillet on the right side. And if I reconnect now the ballast mid to the default, you get the full effect of the balustrade. Now let's put a material on here quickly and render it and see how it looks. So hit M to bring up the material editor. We want the stone material. Just drag that onto the RailClone object. Just getting nice and close and do a quick render. Okay, so looks good, but one thing that's apparent is the repeating texture on each segment. And the great thing about RailClone is that we can get around that by automatically adding box mapping as part of the style. And it adds this box mapping after the geometry's been built, so the box mapping can bridge several adjacent segments. We'll demonstrate this by adding a new material. So open up the material editor and drag the UV default material onto the RailClone object. Now you can see each segment uses its own UV coordinates, creating a very obvious repetition of the texture down the length. We can fix this by applying a box mapping after the geometry has been generated, so that the texture can span several adjacent segments. To do that, come in and pick the ballast mid segment. From the Properties panel, choose Deform, and come down to the Mapping section. Turn on Apply Box Mapping, and immediately you see it update, so that the box mapping now spans at least 5 segments. This is controlled by the length, width and height parameters just here. If I adjust these, you can see in real time the texturing adjusts in the viewport. Length moves down the path, width moves front to back, and the height top to bottom. The texture we're going to use actually has real-world map size, so we can turn this on from here. If I turn it on, the length, width and height segments no longer have any effect, and the size of the map is determined instead in the texture itself. In order to apply this to all the other segments, simply click on them, go to Deform, turn on Apply Box Mapping, and turn on Real-World Map Size. And do it for the last one. If you look at it now, you can see the texture seamlessly tiles down the entire length of the RailClone object, spanning several adjacent segments, including the fillet and the post, and you're going to get a seamless texture using this technique. If I just apply the original stone texture, then we can do a quick render and just make sure that's all working. There we go. You can see now the texture carries on over several of these columns. In fact, it doesn't repeat until about every 5th segment with the map sizes we have set up. There's no visible joins anywhere, and there's no obvious repetition. So finally, let's add the light to the top of every other pillar. Let's go back into the object, back into the style editor, and we've set up some parameters already on this linear array. So instead of creating one completely from scratch, let's just copy the one we have. So click on it, right click on it and copy, and then right click anywhere else and paste. We're going to use the same path in this case, so just click and drag the balustrade path to the new spline input. And we're going to use a new segment. We're going to use this light, so a new segment object. Pick the light from the scene and connect it to, in this case, the evenly input, since we only want it to appear every 10 meters actually. If I apply at the moment, because it's using the existing settings, it's on top of every post, which is great. But clearly it's too low. We need to move it up so it sits on top of the post. And to do that, we can use the transform settings in the lamp properties. If you come over here in transform, you've got the fixed settings that allow you to just make adjustments up or down. And then you've got some randomization that we don't need for this particular example. So let's just pull this lamp up in the air a little bit, and you can see as I'm turning this property up, the lamp is moving in the viewports. Let's just keep going, maybe getting a bit closer. And it's nearly there. So it looks like about 1.09 is probably about right. Okay, so 1.09, 1.096 is about the right place. So that's moved it up, but you can see it's on top of every pillar at the moment instead of every other pillar. And also it's not on the start or the end. It might be nice to have it on the start and the end. So let's connect it to the start first. And you should see a lamp appear there now. And let's connect it to the end too. And then to make it appear on every other pillar, we just go into this new linear array, come to rules, and the evenly distance, which if you recall for the posts was set to 5 meters, we could double to 10. Now you have one on every other pillar. And that completes the balustrade. All that remains now is to come back into your display settings, set it back to point cloud display so we can show the full length, and then turn back on, under base objects, turn back on the full length. Now you'll have a very long balustrade scattering hundreds of high poly objects, seamlessly moving in the viewports. Let's go back to the camera view and do a quick render and see how that's looking. You can see the box mapping is working on the textures. The lights are on top of each other post and go the full length. That's working well. In the next section we're going to look at creating the slabs on the path here using a two-dimensional array, this time using a single spline to govern the length and a distance to govern the width.